Good afternoon, everybody. I'm going to look at a different set of videos, and I believe the ones that I uploaded into the folder seem to have cut off its screen, and so the software I was using didn't follow me down the page. So I'm going to just start over and give you all several other slides in this one video. And you will find it in the Exam 3 folder labeled Rational Exponent Rules. So let's go ahead and begin. And as you can see, just the standard, the standard definition for a product rule is when you're multiplying exponents and they have the same bases, you're allowed to add those exponents. So that's our rule when we're working with, for instance, an example like this where I do have coefficients and I am multiplying. So 2 times 2, I would get 4, and then x times x. So the bases are the same, so I'm allowed, the rule is to add the exponents. So what I would need to find is a lowest common multiple, common denominator, 2 and 4, which would be 4. So 1/2 is the same as 2/4. And I'm going to add 3/4 to that. So my result would be 4x to the 5/4 power. Multiplying, same bases, you're allowed to add your exponents. Let's look at another example. So let's look at part A here. All the bases are m, and I've got coefficient of 2, coefficient of 4, and 8. So if I multiply 4 times 4 is 16, and I double 16, I'm going to get 32. M to the second plus 3/2 plus -2. Now, since I have I'm adding these because they had the same base. Notice that the 2 and the -2 go to 0. So I'm left with 32m to the 3/2 power as the result of part A. Part B, there is a coefficient here with this second expression, and that is understood to be 1. So that would be 3 times 1. And I'm going to get 3b to the 1/2 plus 4/3. Same bases. When I multiply, I get to add the exponent. So my lowest common multiple would be 6. So I get 3b, and 1/2 would be equivalent to 3/6, and 4/3 would be equivalent to 8/6. So that would simplify to be 3b to the 11/6 power. Again, this is the product rule. When you're multiplying exponents with the same base, you're allowed to add the exponents. So let's move on. Now we're looking at the quotient rule. Quotient is the result of a division. And as you see the example here, when I'm dividing with the same bases, I'm allowed to subtract those exponents. So if I have, and that's just dealing with the exponents. So let's say that I have 4x to the 1/2 and y to the -2/3. Let's say x to the 1/2 and y to the 3/4, all divided by, we'll say 8x to the 1/3 times y to the 1/4. So since I am dividing and I have my coefficients, basically I'm not subtracting these because these are coefficients, and I am dividing, so I want to simplify that. So that's going to simplify to 1/2. And I have x, bases of x, and I'm dividing, so I will subtract those. That'll be 1/2 minus 1/3. And the same for the y's. That'll be 3/4 minus 1/4. So that would give me 1/2 and x. So 1/2 and 1/3, so 1/6 would be the common denominator. So 3/6 is the same as 1/2, and 2/6 is the same as 1/3. And 3/4 minus 1/4 would be 2/4 or 1/2. So my final result would be x to the 1/6 power, y to the 1/2 power, all divided by 2. Can't forget about that value divided by 2. So let's look at another example, and we'll look at part A here. And I've got the fraction 2/4, so I can go ahead and simplify that. That's going to give me 1/2. And then I've got x to the negative 7/4, and I'm going to subtract 4/3. And in this case, I'm going to have, I need denominators 12. And 4/3 would be the same as negative 21/12. And this would be, 4/3 would be the same as 16/12, all divided by 2. So I'm just going to come down here. So that would be x to the negative, what is it, 37th 12th power, all divided by 2. And I kind of jumped ahead on this one, but I do have an exponent that's negative, and using our reciprocals, that will allow us to then drop that to the denominator to make it a positive exponent. So we'll discuss more about that in a few slides here to come. So again, when you're dividing exponents with the same base, you're allowed to subtract. So I've got 4 divided by 2 in part A. So that's going to give me 2 in the numerator. And that's going to give me x to the second minus 1/2. So x to the second divided by x to the 1/2. So since I'm dividing, I'm allowed to subtract the exponents. And so that's going to leave me with everything divided by 1. And 2 would be the same as 4/2. Take away 1/2. I'm left with 3/2. So 2x to the 3/2 power. Part B, I don't have any other x values to work with, and I do notice that I have a negative denominator, so I can use my let me erase that, because the 4 is okay in the denominator. It's the power x to the negative 2/3 power that needs to rise to the numerator to become positive. And then I'm gonna leave the 3y to the 1/4 because I need to do some simplifying here in the denominator. So that's going to give me 3 times y to the 3/2 times, or adding 1/2, because since I'm multiplying these, I get to add the exponents. That's our quotient rule. And I've got 4 and 3 here, so that's going to give me 12 in the denominator. That's going to give me 3x to the 2/3 in the numerator times y to the 1/4. And then here, I've got 3/2 and 1/2. That's going to give me 4/2, or 2. So what I have now is 3x to the 2/3 times y to the 1/4. And since I'm dividing, I'm going to be subtracting 2, all divided by 12, because 4/2 becomes y to the second. and so y to the second would be down here. And now, and I'll just go ahead and write that just so that we didn't miss that. That would be based on y to the 4/2, it'd be y to the second. So now I get to divide, and I can divide the 3/12. So that would give me x to the 2/3 divided by 4, and y to the 1/4, and 2 would be 8/4. So again, I'll come this way. I'm going to have x to the 2/3 divided by, and 1/4 take away 8/4 would be -7/4. So bring that to the denominator and it's positive, and I have 4 as part of that. And that's the quotient rule. When dividing by dividing exponents with the same bases, you're allowed to subtract. So this would be one that you can try as a check for understanding. Notice that you're multiplying here. So notice you're dividing here, so you could put it on pause and try these two before you move on. Now, if you've already tried them, so multiply them, I'm going to get 12x, and now that's going to be 2/3 plus 1/5. Common denominator would be 15, so 12x to the 15th. And 2/3 would be the same as 10/15, and 1/5 would be the same as 3/15. So I would get 12x to the 13/15. It's hard to read that. So 13/15 power. Part 2, I'm going to use the quotient rule because I see division. So I'm going to get a to the 2/3 minus 1/3. So that'll be a to the 1/3. I get x. I get 4/5. Take away 2/5. That's going to give me 2/5. And y will be 3/4 minus 1/2, which we know is 2/4. So 3/4 minus 2/4 would be y to the 1/4. And I could simplify that, because what's the cube root of 8? That would be 2. X to the 2/5 power times y to the 1/4 power. Negative exponents, talked about that earlier. And what we have is, if you have looked at some patterns in class the other day. So if we have like 3 to the 3rd, which we know is 8, 3 to the 2nd, which is 4, 3 to the 1st, which is 3, 3 to the 0. And so you start looking at what's happening to your patterns. You're dividing by 2. That's incorrect. Sorry. Maybe I was thinking power of 2. So 3 to the 3rd would be 27. 3 to the 2nd would be 9. 3 to the 1st would be 3. So everything's dividing by 3. So that would be, 1 has to come next. 3 to the negative 1st would be 1/3. 3 to the negative 2nd would be 1/9. And another way to write 1/9 would be 1 divided by 3 to the 2nd. So if you look at how these are compared, 3 to the negative 2nd power becomes 1 divided by 3 to the 2nd power. So we can use the reciprocal idea in simplifying. So if I had 4 to the negative 2 power in the numerator, it would be equivalent to 4 to the positive 2 power in the denominator. And vice versa, if I had 1 divided by 4 to the negative 2 power, it would move to the numerator using the reciprocal and become positive. And some other examples, we just noticed that 3 to the 0 power was 1. Well, we could say, what's 3 to the 3rd divided by 3 to the 3rd? If we expanded it, you could see that all the 3's would divide out, leaving you with 1 divided by 1, which is 1. We could use the quotient rule, and 3 to the third divided by 3 to the third would be 3 to the third, 3 to the 3 minus 3 power, which would be 3 to the 0 power, which would be 1. So anytime that we see a number or a variable raised to the 0 power or expression raised to the 0 power, we can give a result of 1. And then final, we've got the power to a power rule. Notice that if we've got a base raised to a certain power and that entire expression is raised to a power, we are allowed to multiply the exponent. So if I have 2 to the 1/4 raised to the 5th, then I can multiply 1/4 by 5, and I'm going to get 2 to the 5/4 power. If I have x to the 1/3 raised to the 1/3, then that would be x to the 1/9 power. And then one final check for exponents, check for understanding. So I'm dividing. So I'd be using the quotient rule. So 8 divided by 4. So number 1, 8 divided by 4 would be 2. And x to the 5/8 divided by x to the 3/8 would be x to the 5/8 minus 3/8. And that would be all divided by 1. So I'd get 2x to the 2/8 power, or 2x to the 1/4 power. Number 2 is one of those that doesn't take you a whole lot of time at all. Why? Because everything's raised to the 0 power. So that means everything inside the parentheses will result in 1. And then finally, number 3, you're taking everything inside the parentheses to the 1/4 power. So 2 to the 3rd will be multiplied by 1/4. X to the 2/5 will be multiplied by 1/4. And y to the 2/3 would be multiplied by 1/4. So anytime you raise a power to a power, you're allowed to multiply. So that would give us 2 to the 3/4 power times x to the 2/20 power times y to the 2/12 power, and then try to simplify what you can. So it'd be 2 to the 3/4 times x to the 1/10 times y to the 1/6. So those are some examples going over the rules for rational exponents, very similar to what you would have with integer exponents, except the exponents we're working with today are fractions. Hope you enjoyed this. Definitely use this during your week, and you may reference these as you work your quiz that'll be due next Tuesday, November 1st. All right, y'all have a good day.